So, hello and welcome, friends. From today's session, we are going to start a new series. It is on the power system. So, basically, today, from this session, we are going to start a series on power system. Right now, why power system? Because there are many advantages of power system. If we talk about the power system, then it is the core subject of students that are in the electrical engineering, right? So first of all, it is the core subject, and the sound knowledge of the power system will definitely help them, right? Secondly, power system is the subject that is it is always there in if we take any kind of government exams, right? So yes, if it is for the state electricity board, right, or it is suppose if it is for RRBJE or SSCJE, right? So power system is definitely going to be there, and this subject is mainly targeted in such a way that we can target government exams, right? And after that, if any students are appearing for the gate, right, so in that way also this subject is going to help you, right? And in this series, basically we will cover each and every aspects of the power system in very deep manner. So yes, let us start power system. Okay, so if we talk about the power system, basically if we see that electricity, we know that electricity is the integral part of our life, right? And it is the basic need. Now uh, for development of any country, and for any industries, and to develop any infrastructure, right, electricity is going to play a huge role in the industrialization, or for the development of any country. So yes, electricity is definitely there, and in infrastructure we can also let us say medical infrastructure, right, educational, also we can include commercials, right? So yes, there are many infrastructures that need electricity, and this electricity is basically the basic need of this infrastructure. They cannot they cannot stand a day without the electricity. And if we see our daily life also, we cannot stand a day without electricity. In our daily life also, there are many appliances. If we see, we have mobile, we have fans, right? Laptops we have, or computer, right, or tablet also, right? So these appliances are there. Also AC is there, fridge, washing machine, right, TV, right? So we cannot stand a day without these appliances, right? So yes, electricity is the basic need of this. And now if you want to understand the need of the electricity and how electricity implies on the growth of any particular country, so we can say that suppose if we take the example of 10 to 15 years back, at that time we didn't have mobile, right? Suppose at the time we have landlines, and now if we see ourselves, we have mobile, right? At that time we have only fans, and now we may have coolers or ACs, right, along with the fans. At that time we didn't have any kind of computer. Now we have laptops or PCs, or may have tablet, right? So if we compare, suppose this is the example of 1990s, right, and this is of 2000s, right? So in this, the span of these years, we have many appliances. That means what? The need of the electricity consumption, or the electricity consumption from each and every individual has been increased. And if you see that first we didn't have this kind of appliances, and now we have these appliances, that means what? There is a growth in ourselves, right? There is a particular growth, that could be a financial growth. At the first we are not able to purchase these appliances. If they were available also, then also we were not able to purchase it because of the any financial issues or whatever the thing is there, right? But now if we see, we have these appliances, and that is also multiple. If you see the mobile, if you take mobiles, and many people have 2 or 3 mobiles, right? and many people have 2 or 3 ACs. So in that way, our electricity consumption has also increased, and that particularly shows the growth of our each and every individual. So if we take the example of individual, then also it shows the growth in terms of electricity consumption. And now if we take any particular country or any particular state, then also it will show the growth of that state or that country by figuring out that whatever the electricity consumptions are there in in particular area. So that we can definitely do for suppose we can say that per capita, if we take the example of any country, what is the per capita electricity consumption, right? So that we need to figure out, right, what is the per capita electricity consumption of any country, right? And that shows the growth of that country. Suppose if we take the example of India in 2014, the per capita electricity consumption was around 800 kilowatt hour, right? And at that time USA was around 12,000, right? So you can see that what is the difference between the growth, or what is the difference between the electricity consumption, and also we know the difference between India and USA, right? And similarly, what we can say that suppose if any country that is having electricity per capita electricity consumption was around 800 kilowatt hour, and now if we take the example of 2019, and it is having the electricity consumption of 1200 kilowatt hours, right? So this particular thing, the change in the electricity demand or the consumption, it definitely shows the growth of that country, right? So to measure the growth of the country, electricity consumption is also important. Now we'll take the power system, right? We have understood the meaning of the need of the electricity. Now we'll take the example of power system. See, power system is basically having the three components, right? One is generation, second is transmission and distribution, and at the third we have utilization. See, if we talk about the generation, then generation is very important. As the country is growing, the electricity need or the demand of the electricity is also increasing. And if we take the example of India, here the demand in the electricity is rapidly increasing, right? So the thing is, to meet that demand, we need to increase our generation capacity, right? Currently we have around 300 gigawatt, that is our generation capacity. Now the thing is, we need to continuously increase this generation capacity. And what are the different ways through which we can generate the electricity? Currently, if we take, so our main source of electricity is coal based power plant, or we can say the thermal power plant, right? So it is having around 60% weightage, 60 to 70% weightage in the generation. Then we have hydro power plant. Through the water, we build the dam, and from which we get the turbine and alternator installed over there, and from that we generate the power. So that is hydro power plant. Then we have nuclear, we have gas turbine, we have nuclear has been there, so we have diesel, right? And also now we have the new sources, that is renewable energy sources. See, the thing is, currently the coal based or the thermal power plant, that is playing a huge role. It is around it is generating around 60% of the installed capacity that we have, 60% of the generation capacity. So coal is playing the huge role in the electricity generation. But now the thing is, it is also playing a huge role in the pollution, right? It is also playing the huge role in the pollution. And second thing is, if we see India's current situation, whatever the climate change that has been there, right? If we see in the 2019, we have the climate change, or we have the increased temperature, that is of 0.8 degrees Celsius only, right? And due to this 0.8 degrees Celsius only, we are observing so many cyclones, we are observing so many floods, right? We are observing earthquakes, right? So these all things are happening just because of only 0.8 degree increase in the temperature. Now if you see the generation thing, right? So thermal power plant, basically, if we talk about the total generation, then it plays around 38% in the pollution that we are having. It plays around 38% in the pollution, or global warming also. So basically, and the first point is it is causing the so many pollution, and the second point is we don't have so much coal, right? The coal is the problem also, so we don't have so much coal around. We may exist, the coal may exist for 200 years. So that is the whatever the thing that we have. So we have coal for around maximum for 200 years, and that is the second reason. So that we also have to move for the alternative of the coal and thermal, right? And when we are finding the alternative of the coal and thermal, the thing that we need to keep in our mind, that it should be freely available, right? It should be freely available, it should be abundant. Sorry, pardon me for my handwriting. Yes, it should be freely available, it should be abundant, right? And it is also reliable, and the main point, it should be pollution free, right? So these are the things that we need to keep in our mind when we are finding for the alternative of coal and thermal based power plant, right? So the most preferred alternative for the thermal power plant, that is renewable energy sources. And the thing is, government is also very much concerned about the solar and wind based power plant, and government has also targeted around 100 gigawatt power generation from the solar, right? And that is the target, and total 175 gigawatt from the renewable energy sources by the end of 2022, right? So this is the target from the government itself. And if we see current situation, till now we have around 29 gigawatt generation from the solar, 28 or 29 gigawatt generation that we have currently in the solar. So we are meeting the target, but yes, we are behind the target. So if we have around 2 years only, and in 2 years we have to cover around 70 gigawatt. So yes, we are running behind the target. And the second thing is, renewable energy sources are going to be the future of any country. And if you want to control the climate change also, at that time also renewable energy sources will play a huge role. So okay, so this is all about the generation. Now we talk about the transmission and distribution. Okay, so the thing that we have understood from the generation is, we need to generate the power in very bulk manner, right? Bulk power generation should be there. Okay, so now the thing is, this power generation could not be done in the city area itself. We have to we have to generate the power in the remote area. If you take example of the UP, then the generation of that particular thing is in the particular area, and the consumption and the industries are in the other area, right? So yes, so the thing is, the bulk power generation is basically done at the remote area, right? And our consumers, right? Our consumers is basically, it could be on any particular area. So we have to transmit that power to our consumers. So that is the requirement. And if we see transmission area or the transmission network, right, it connects the generation and distribution system. So transmission system connects generation system and the distribution system. Now this transmission network is basically carrying the bulk power, right? Whatever the bulk power that is generated at the generation station, that bulk power has been transmitted to the distribution system. And secondly, the thing is, it is the transmission lines operate at very high voltage, right? And there is a reason behind this, that why transmission network is operated at very high voltage. We will cover that in our next video also, that why transmission network is operated at very high voltage. Okay, so the thing is, transmission network is basically any country is having the transmission network, and transmission network is, we can say that we can also call it the grid of that particular system. And if we take the example of the India, right, if we talk about the India, in India we have one nation, one grid, right? But before that we have 5 regional grids, right? See, these transmission network are interconnected. This transmission network of a particular area or particular state is interconnected, and they form a regional grid, right? And these regional grids are interconnected and they form a national grid, right? So that is how in India we have, right? So but in India we have 5 regional grids. One is eastern, then we have western, third we have southern, then we have northern, and we have eastern and northern, east northern, right? So these 5 grids we have, and we'll see that how these grids are that which are the different areas it is covering. So this is the interregional grids that we have. Here you can see that this particular thing is northern region, right? Northern region grid it is having. Here we have eastern region, here we have northeastern region, this thing is western region, and this is the southern region. Okay, so these here the areas that from here, that is all the north region. And similarly the western region covers Gujarat, Maharashtra, right, and this area. Similarly we have southern region grid, and this particular area is eastern region, and this is our northern region grid, northeastern. Okay, so they have the different capacities, and they are interconnected to form the national grid, right? And there is a particular evolution in the grid, and we will see that how this our grid has been evaluated, right? So basically initially the idea has been started, right, in the 1990s, right, where you can see that in the October 1991 northern, eastern and eastern grids, they were connected, right? So first interconnection has been established in the October 1991. After that, in the 2003 March 2003, western region grid and eastern region, northeastern region grids were interconnected. So at the first, northeastern and eastern grid were interconnected. After that, western region has also been connected to that connection, and after that in August 2006, north and east grid, they are interconnected, and thereby 4 regional grids, northern, eastern, western and northern eastern grids, are synchronously connected, and they form the central grid operating at one frequency, right? In India we have 50 Hertz, right? Our operating frequency is 50 Hertz, right? So all the grids now operating at 50 Hertz, and at the end, at 2013, December 2013, the southern region has also connected to the central grid, and yet it has formed the one nation, one grid mission. Right, so this is how our national grid has evaluated, and this data has been there in this website, Power Grid India. So you can also check out the website also to get the more information about the national grid. Okay, so this is the concept of the grid. And now we have been talking about the transmission system. So that was about the transmission system. Transmission system carries, it connects the generation station and the distribution system. And transmission system is having a bulk power. It is transferring the bulk power throughout itself. And it also is having the high voltages. It carries the high voltages. Now if we talk about the distribution system, right, then a distribution system basically connects the medium or small scale industries, right. It provides the power, it supplies the power to medium or small scale industries. Or again we have the domestic loads, right. Domestic load, that means whatever the fridge are there, fans are there, ACs are there, TVs are there. Or if we see residential area, right, so domestic load covers the residential area, so it provides the power to the domestic load also, right. So and again in the next videos we will see that which are the different loads that we have, right. So the load portion also we will cover, but this video is particularly for the structure of the power system that we have, right. So distribution system basically covers this kind of loads. It supplies the power to domestic loads as well as the industrial loads. Okay, and we will cover more things about this. Now the thing is, we will see that how the power system is structured in India. So we'll see the power supply system of India. See, first thing, it will start from the generating station, right. So we have generating station. It could be thermal, it could be hydro, it could be anything, but mostly we have the generation from the thermal power plant. So we'll consider thermal power plant over here. So the generation that we have in India, that is at 11 kilovolt or 11 kilovolt to 25 kilovolt. So in the particular range we have the generation, and basically the mostly 11 kV we have the generation voltage, and this generation voltage is stepped up using the step up transformer. Right. So there is a step up operation, and the step up operation is from 11 kilovolt to 220 kilovolt, or it could be 400 kilovolt, or it could be 765. Maximum we have 765 voltage we have in India. And after that, if you want to go, then we have HVDC system. So the transmission voltage in HVDC system, it could be 800 kilovolt, it could be 1200 kilovolt, right. But this is totally different thing, right. In India we transmit the power in the AC manner only. We have the HVDC system in India, but that is in the few in the limited area only. Okay, so there is a step up operation, and this step up voltage is now transferred using the primary transmission network. So transmission system is also having a two parts: primary transmission system and secondary transmission system. So first this step up operation is done, and we have the primary transmission, that is transferring the power at 220 kV or 400 kV or 765 kV. After that, this high voltage is stepped down, and the step down operation from 220 kV to around 132 kV, or we can have 66 kV, right. So yes, so we have the step down operation, and then we have again transmission, and that is done through the secondary transmission network, right. So yes, we have the secondary transmission network, and here we can have the interconnection from the local power supplier. Any independent generator is there, so they can also feed their power. So we have the interconnection of local power suppliers, right? Or from the secondary transmission network also we can supply the power to the large industrial areas who requires the load or who requires the power at large voltage. So we can also supply the power to the large industrial area. So from secondary transmission network we can have the interconnection from the local power suppliers, and we can also give the supply to the large industrial areas. After that we again have the step down operation using step down transformer, and this step down is basically from 132 to 33 or 66, and from 66 to 33, right? It depends on the input that we have. Okay, so this step down, after that step down we have the primary distribution system, right? After that we have the primary distribution system, and this primary distribution system, it basically supplies to the medium or small scale industries, and also we have the interconnection of the small power suppliers, right? So we have the interconnection also. Here it maybe we have 33 to 11 kV, right, or 66 to 11 kV that we have, right? So after the primary distribution system, again we have the step down operation using the step down transformer, and this step down operation has been done from 33 to maybe 11 kilowatt or 11 to 400 volt, right? And after that we give the supply to the domestic loads, right? So इस तरह से in this particular way we get the electricity at our home, and domestic load is basically we consider it is our home, right? So this is the proper structure of how our power that we are getting from any generation station, right? So I hope that you are very much clear in this power supply system. If you have any kind of doubt, you can put it in the comment box. I will definitely read it and reply you. And if you have not subscribed the channel, please subscribe it. We are going to make so many interesting videos on the power system, and we will cover so many MCQs also, so that it can help you in cracking the government exams or any kind of if you are appearing for the GATE exam also, so it will definitely help you. So thank you guys for watching. We'll meet you in the next video.